Whenever we do a lab activity, we will also write a lab report. The purpose of a lab report is to organize and communicate what you did in your experiment. This same grading rubric will be used for all lab reports throughout the year. In particular, every lab is going to have data tables, graphs, and conclusions, so you should pay especially careful attention to those requirements in this rubric. It would be a very good idea to refer back to this rubric and use it as a checklist before turning in any lab report. We will do almost all of the first report together as a whole class in order to model these requirements. But after that first lab report, it's assumed that you understand this rubric, and also you know that you can always refer back to it, and you can ask me questions if you have a question about what this rubric means. Okay, so the first part of the rubric refers to organization, and essentially every lab report should follow this sequence. Note that you should always provide the full names of every team member, and of course yourself. So full name means first and last name. Every lab needs to have a clearly stated purpose, and you should identify both the independent and dependent variables and what variables are held constant in the experiment. A note about the constants. Please provide specific values for every constant. For example, it wouldn't be good enough to say the inclination angle is held constant. You should give the amount of the inclination angle, for example, 2.4 degrees. Okay, so you need a specific value for each constant. The style requirements are that the lab should be typed and double-spaced. Any equations should be created using the Word equation editor, and they need to be centered on their own line. In other words, equations should not be embedded within the text. They need to be centered on their own line so that they stand out and are very visible. White space really helps to make the report more legible, so please don't try to just cram information into odd spaces like to the side and everything like that. Each section should come sequentially in the proper order, and each section should have its own subheading. If at some point a mistake is made, it is okay to just put one line through that data or even through that sentence, and then label with some type of explanatory note, and then you can write a revised data point or sentence above what you crossed out, but never erase data. The requirements in this rubric for the data table and graphs are consistent with what you read on experimental design and data analysis a few days ago. Okay, so regarding data tables, it's very important that every table have a header, and the header should give the name of the variable in each column along with the units of measurement. The independent variable needs to be located on the left. At no point should data ever be erased or blackened out. If a mistake is made, that's fine. Just draw one line through the point and write a note in the margin to the right of that table. If there's not room in the margin, you could put that note at the bottom of the table. Okay, calculated values. A lot of tables will have a column that has values that are calculated. For example, many times you calculate the average of several trials and show that average value. For any column that has a calculated value, you need to show below the table how that calculation was done. So you would show the details of the calculation for a single row of the table. The reason you're doing that is so that your reader can understand exactly how the values in that column were calculated. Okay, graphs. Notice that graphs account for a large number of points in this grading rubric. So mistakes here can really lower your grade. It's important to be careful to do the graphs correctly. For the first few labs, we will do graphs by hand. Then we will begin using computer, for example, Microsoft Excel or other software to generate the graphs. So there are requirements for both types of graphs in this rubric. Let's look especially at the graphs done by hand, since those are the ones we'll be doing initially. It's very important that these graphs take up an entire page of graph paper. The scale needs to be selected so that the data spreads out to be nearly as wide and as tall as the paper allows. Certainly draw these graphs in pencil. It's very likely you'll need to erase. Data points need to be clearly marked with some type of symbol. I'll just go to this picture, which is in the reading on experimental design and graphical analysis of data. Notice that there's a circle drawn around each data point. In this reading, it called that a point protector. What we're trying to do is to make sure that the faint pencil marks will not be overlooked. They might get overlooked because they may be lighter than the grid of the graph paper. The trend curve, for example, the line of best fit, if it's a linear relationship, needs to be drawn using a ruler, a straight edge. If the trend is not linear, then you'll do your best to draw a smooth curve by hand. Do not connect the dots. With real-world data, it is very likely that one or more of the data points will not actually fall on the line of best fit, and that's okay. Make sure that you can extend the line to cross the y-axis so that you can read the y-intercept from the graph. Okay, and then a final point, which is very important. When you have a linear trend, you're going to be calculating the slope of that line. And so you'll need to choose 2 points from the line of best fit to calculate that slope. These 2 points must not be the original data points. They must be 2 other points from the line of best fit. Use a different symbol to represent these 2 points that are used to calculate the slope, and write the x, y coordinates of those 2 points just above each point. All graphs need to have a title centered above the top of the graph, and the title needs to have the format of dependent variable versus independent variable. For example, displacement versus time. Never put units of measure in this title that occurs above the graph. Each axis of the graph needs to be labeled with the name of the variable on that axis as well as the units of measurement. And each axis needs to have its scale labeled across the graph. And each scale has to have a consistent value for each block as you go all the way across that axis. Now, it's very likely that the horizontal and vertical axis will have different scales. That's okay, but on the same axis, each block needs to represent the same amount of units. The analysis portion of the lab report primarily involves finding the slope and y-intercept and writing the physics equation. You need to show the detailed calculation for the slope, show exactly how you found it, and you need to give the units of the slope. And be very careful when you write the physics equation to follow all of the rules for how that physics equation is formatted. use descriptive variable names, and the name must not be the units of measurement. For example, if you were measuring length in meters, you might want to name that variable L for length. You would never name that variable M because the variable is measured in meters, so we would never use M, which is the symbol for meter, as the name of that variable. Also, you put units on both the slope and the y-intercept, and put the slope with its units in parentheses, but that should be the only set of parentheses in the equation. Never put parentheses around the variables, and also never put units on the variables. The conclusions of the lab need to be typewritten, double-spaced, and written in complete sentences. Always summarize the purpose of the lab. A lot of times this can just be copied from earlier in the lab report. And for every experiment, you're going to provide this list of information. You'll realize after we do a couple of lab reports that there's kind of a rhythm or a repeatable model for this type of paragraph. And if you'll pay attention to it, you will see that you can write this in a similar way for every lab. So first you state the type of relationship. That basically means, what was the shape of the graph? Was it linear? Was it a parabola? Was it an inverse relationship? Something like that. If the relationship was not linear, then you will need to explain how you linearized the data so that you could find an equation to fit it. Then you'll provide the physics equation of that linearized relationship, and you will explain the meaning of the slope, and then explain the meaning of the y-intercept. When you write a lab report, be careful with your to observe all of the same conventions and style of writing that you would if you were writing for English or history. Wording choices are important because it's important to be specific and accurate. Avoid ambiguity. In particular, be very cautious about using pronouns such as it. Instead, always be very specific. The position versus time graph. Don't just say the graph. Give the name of the graph as you refer to it, for example. If you have time, it's a very good idea to read the conclusions aloud to yourself so that you can check that the writing reads well. If it reads well, it will be easy to understand. So use good sentence structure and nice transitions between paragraphs. And then, of course, pay attention to spelling, punctuation, grammar, and the use of paragraphs.